Good morning, everyone. Nice to have everyone on board. My name is Lilian Wanzare from Maseno University in Kenya. I am a computational linguist, and I work a lot with natural language processing, particularly for low resource languages spoken in Africa and those spoken in Kenya in particular. And one of the fascinating aspects that we are really working on is understanding the concept of Kenyan Sign Language and how can be able to develop tools that are able to translate from spoken English to Kenyan Sign Language. So in this session, I'll be giving you a brief on what we did towards this project of bridging language barriers using AI for Kenyan Sign Language among the deaf learners. So I'll immediately go into the presentation, and I hope you find it fascinating. As a background, we know that language is a human right, yeah, and is a way of communication that everyone must be able to communicate with people around them. And also we know that approximately around 50 million people around the world are actually having hearing impairment, yeah? And most of them, it's interesting that actually most of the hearing impairment children are born in hearing families or families that have hearing parents, the particular matter, okay? And if you can imagine that, so it means that from the beginning, if their parents or their siblings in their families are not able to communicate in sign language, they're already left out, okay? And they're not able to integrate easily within the hearing if the hearing are not able to sign, okay? So we're looking at different works in terms of understanding. One, within the Kenyan context, there is limited availability of sign language, okay, interpretation, and think about it in school setups. It is not possible to have, sign language interpreters in every single classroom, okay? So what kind of tools are we able to develop such that even those who have hearing impairments are able to participate, especially within the classroom setup? So in this project, we adapted the AI4KSL projects, and the goal was to be able to develop assistive technology that is able to translate from spoken English to Kenyan Sign Language using signing avatars. Why English? Is because in most of our schools, the language of communication is English. So it was really natural for us to say, let's start working on English as the medium of instruction at the schools. Now, to develop this project, we thought about what is the team that we need to be able to have. And there are different facets if you look at it. One, of course, we need the NLP developers. Those are going to develop the actual tool. But before that, yeah, we want to have the sign language experts. Those who understand the sign, the nitty-gritties of the signing concepts. Those who understand this deaf community. How do we get access to the deaf community? Because they're the ones where we're going to collect the data from. And because you're going to use this tool within the education setup, what about pedagogy? Okay, how do we integrate this tool within the classroom setup? How do we evaluate it? What will the students think about it? What will the teachers think about it? Yeah. And lastly, we need an education technology expert who really understands the interplay between technology and education. So we are really a team of around 6 co-PIs who are working with this particular project. In a nutshell, we developed this kind of high-level methodology to look into it. So first, let's understand the sign language as it is spoken within the classroom setup and within the community at large. So we went out to collect data, where data is just the words, the sentences, the videos of different signers signing these particular sentences. And then we move to the next step. Once we have the data, how do we represent it in a way that now the computer or the machine is able to really understand it? And lastly, then how do we move that into a signing representation? And remember, we're talking about a low resource setting, okay, where we don't have enough data to be able to have an end-to-end kind of system. So the first objective, we want to be able to build a data set of spoken English and recordings of Kenyan Sign Language. So this particular task, we went out to different schools for the hearing impairment. So in Kenya here, from the primary to high school to some tertiary education, so we have special classes that are particularly for the hearing impairment. So it means that you're able to go out to school and everyone in that school is either hearing impairment or is somebody who understands sign language. So we record them as they sign different aspects within the sign language. And we follow the curriculum. There's a sign language curriculum that is taught in schools. So we follow the curriculum to learn which words are they taught and how are they signed. And we have a huge database of recordings of different signs, capturing variations because we know there are people have different ways of signing. We have regional variations because different regions could be able to sign differently, even though we have an official sign language curriculum, but there are definitely some regional signs. So we have this data set that you have built over the course of the last 2 or so years. Okay, so they are about, by now, there are more than 6,000. I think there are about 10,000 sentences. And in sentences glossed, where glossing is just a representation that is a morpheme by morpheme translation of the English words into a way that it is signed. I'll explain that in a minute. So for instance, in English, we have the object, the subject, and the verb. But in the glossing, okay, if you think about it, we have the subject, verb, and object. But in the glossing, they always start with the object and then the subject and then the verb. So just a way of translating the English into how they typically sign. We mean by the gloss. So we have that representation. So an example, think about, example 2, a bee stings. We have that as in English, and in the sign language, you'll have it in terms of bee sting. Okay. Or for instance, a cheetah runs fast. It will be cheetah, run fast, or cheetah fast, run. And those are ways that how they sign the particular sentence in English. How did we record? Because of limitations of funds, we had a front-facing camera only. Ideally, you should have a 3D camera. So the front-facing camera records the signers as they sign, okay? And the videos are stored. And then later on, we have a group of signers who now go through the videos verification, and they demarcate the beginning and end of every sign within the sentence. Because if you have a sentence like, I am going to school, there is a sign for I, sign for going, sign for school, for instance, and each of them needs to be demarcated to help us to be able to train models after that. So the data set contains the videos themselves, the audios of the sentences that are being signed, and finally the segmentation of the videos, demarcating the start and end of every sign within the given video. The second objective we're thinking about, now we have the data sets. Now, how do we represent this? Okay, in a way that now you're able to build models around it. Yeah, and we went around, and there are many propositions that have been researched the recent past in terms of how do we translate or how do we build models that are able to translate from spoken language to English. And within our resource setting, we're looking at one that is able to enable us to sequentially grow in terms of more rule-based kind of systems, okay, with bits of machine learning in between, capture different aspects as we develop. So we chose one technique that looks at moving from text to gloss, okay? Then once we have that, we have the videos, and we extract what we call the pauses. We'll look at it in a minute. And then we are now able to use the pause as an input to an avatar generation machine. So text to gloss, and then video to pause, and then we generate the avatars from the different poses. So in those 3 different steps. So let us break them down one by one. So one, we have understood the gloss. The gloss is you have a text. There's a way the text is signed, okay? And as they are signed, we are able to record in a video how the finger moves. The index finger is moving, how the cheek is moving, how the face is moving. We are capturing all those sign description within the video. So the question is, how do we map this description of the sign in the video? How do we extract it from the video so that we know that if you're signing animal, it is this? Okay, so how do we extract the sign away from the video itself? So this is the full process that we adapted from previous research. So we have the text. From the text, we develop the glosses. From the glosses, we have remember when we are representing the videos, we segmented every video, demarcating the start and the end of every sign. So now we have, for every single video, we have a unique sign that is part of a sentence, okay? From the different videos, we're able to extract the pauses, where the pauses are just representation of the sign abstracting away from the signer themselves. So it's just a recording of the sign. And how do we do that? We use pause extraction models that are able to extract the movements of the hands, the movements of the face, and abstracting away from the individual water signer. And then from those pose estimates, we're able to generate now the videos representing the different water signs. So in real time, we move from text that the person is asking or the person is talking about, we get the corresponding sign that is presented in terms of a gloss representation, and then a pose representation, and a finally generation of the video from the different poses. What do we mean by extraction? So for instance, if I play this first video, there's somebody who is recording a particular sign. And you can see the pose extractor is able to map the movements of the face and the movements of the fingers. So if you remove only the movement and leave the person, you're left with the pose, okay? That shows the movement of the fingers, the movement of the face, and this is what we use to train our models to be able to develop the output, which is an avatar. As you can see, we have anonymized. We are kind of abstracted away from the person, and now we're focusing on the data itself, which is the pose estimation of the original sign. So we have released this dataset. Is around 30,000 videos. Is published in Data in Brief. So we have released all the landmarks and we have released all the poses for the signs. And the research community are able to use this dataset to even train models around sign language, particularly the Kenyan sign language. So our contribution so far is over 14,000 sentences, the corresponding glosses, and then the videos. Each particular word has at least 3 signers, so we have variations of the signs, okay? Each video is segmented with the corresponding start and end of the different signs. And then you've released all the pose estimates and the landmark, the different videos. And we also have a model that moves from the text itself to the avatar representation. It's a bit work in progress. They're still working on it, especially in terms of synchronization and in terms of time latency from moving from the corresponding audio to the corresponding avatar generation. In the last bit of it, we focus on now evaluation. So once we had the prototype model, we want to ask ourselves from a pedagogy point of view, how will the learners respond to such kind of tool? How will the educators respond to such kind of tool? How will it be used in a classroom setup? What kind of infrastructure will the schools need to be able to adapt this? So we went out to different schools. We went out to primary schools. We have gone to secondary schools, and we have gone to tertiary institutions to just see what do they think about it. And we have the students interact with the system, and we ask them questions that they answer in a questionnaire to really understand, are they okay with the output of the signing avatar itself? Is it doing the signs as per the expectation? Okay, if they were to use it, in class, how would they want it to be used in the class? Okay, and if the learners are able to appreciate this, then we're able to get feedback on now, how do we go back improving this? This has been not just at the end, it has been a continuous effort. From the beginning, what do they give us feedback? To the middle, towards the end, how do they want this to work for them within the classroom setback? And we got some interesting feedback from them. But to guide us really as we went through the process, talk about they really were concerned about privacy, okay? Because they are students and some of them do not want the images to be, in a data set being published out publicly, How do we handle that no privacy information is shared out publicly? And we went with the anonymization technique. And they're also keen on fairness. Is the data set representing all their variations of the signs, both female and male? Because sometimes there's some, even gender differences in signing, okay? So we went about making sure that our data set corresponds to at least a majority of the different ways that they actually sign, okay? And as we develop the models, are they confident on how the models are producing the output? The issue of transparency and interpretability. And that's why we chose this kind of technique that goes step by step. But even them, they appreciate and say, okay, from here to here, we're okay with it, And that kind of gives them confidence in the system that you're developing. And lastly, we have the issues of reliability and accountability. As of now, as they test and play around with the system, from their point of view, is it reliable? Okay, is it producing the kind of output that they expect? And we really think about them as in terms of principles, so that at the end of it, there is some kind of adoption of the system that we develop from this particular process. We face some challenges. Okay, we know that signs vary sometimes. Okay, and we also know that there are different levels of expertise in signers. Some people are more expert signers than others. So we have to be able to rely on our expert signers to verify each individual video and confirm that it is the right signing. It is possible that from a layman's perspective, you may think that the person signing is doing the correct thing. But from an expert, they say like, okay, this is the wrong spelling if I use that word. Okay, it's not the correct way of representing the sign. So they're able to sift out the correct vis-a-vis incorrect. Okay, and right now you're facing the issue of latency. Yeah, it kind of requires a lot of technology or a lot of infrastructure to be able to have, the translation move in tandem with the speaker's speed. As the person is speaking is a bit faster, corresponding to the time to which we move from spoken language to the output, which is an avatar. So there's a bit of challenge there, but it's really in terms of infrastructure, because it requires a little bit of models to run behind the background, and there are costs that come with hosting and running these kinds of models. Okay, and that is so far what you have been able to produce, and we hope that the tool will be beneficial to the community, the sign language community in Kenya, but in general to the NLP community as they work with the data and play with the system. So thank you so much for your time.